So today I have bulb with me and wire or some wires I have with me. So to glow this bulb, what we require? We require electricity. So we have electricity supply, and how much power we are consuming, we have a meter outside. So we get current bill. In the current bill, we get power consumption in units. Have you ever wondered what are these units? And if we want to go to shop and buy an bulb, we ask, give me 60 watts bulb or 100 watts bulb, and if you see on the bulb it will be written 220 volts. Then what is the difference between this watts and volts? When the bulb is on and off and the light is going dim in the room, we say voltage is down. So we use so many terms, but we don't know what is the exact meaning of that. So to know the meaning and to know what it is clearly, let us get into the topic. So till now, if you have not seen my activity of paper electroscope, once you see that, so that you will get an idea about the charges. So to get into the topic about charges, let's get into detail things. What is an atom? What are the things present in it? Okay. See, I have some wires with me, like electric wire, and in this wire most of us know that copper outside insulation will be there so that we won't get shock, and inside copper wire will be there. If you open and see, and you might have seen some electricity people, they will be removing that outer cover and wiring. So why this is insulated is we get electric shock if we don't insulate it, because copper wire, current passes through the copper wire. So what is this copper wire? It is a metal. So what is this metal? So metal is a conductor. Okay, so metal is conductor, and the outside insulation which we have given, so that we won't get shock, is called as an insulator. So conductor means this. For example, what is conductor? Let us understand first. We have conductors, semiconductors, insulators. So if we take this copper wire, what is present inside the copper wire? Actually it is a metal, so it has copper atoms in it. I made a video on atoms, elements and molecules. You can watch that. You will have a clear idea what is atom, element and a molecule, and whatever the doubts are there, it will get cleared. So a copper is a metal and it contains copper atoms in it. So what does this copper atom contain? Again, this copper atom, if you observe in detail, it is just compare it with a solar system. At the center we have a sun and surrounding planets. Same way, a copper atom or any atom contains at the center nucleus, and electrons will be revolving around it. Okay, so what does this nucleus contain? It contains protons and neutrons, and electrons will be revolving around it. So like I am giving you so many words telling you about protons, electrons, neutrons. So we didn't see with our naked eye how to understand this. So let us do an activity. So to do this activity, I have scale, then some pieces of paper and this wool. Now I'll rub this, using this wool, I'll rub this scale. See what happened. The papers, you can see they are getting attracted to the scale. If you have observed, see how they are getting attracted. Once again I'll show you. See the movement. So what is happening is I am rubbing woolen with a scale with the woolen. Then what happens? That there is something, a substance which is getting transferred onto the scale, and this is the reason the scale is able to observe, attract the pieces of paper. So by convention, we have given them name as charges and named as positive and negative charges. So what is an electric charge? Electric charge is property of any substance, like property of a woolen or property of a plastic or property of this paper, due to which they are able to exhibit electric or magnetic properties. Okay, that is electric charge. It is a property of a substance due to which these substances are able to exhibit electric or magnetic properties. So what actually you have observed is this electric charges have transferred from this wool to the scale, and from scale they are able to, scale is able to attract the papers only because of these charges. So why I have shown this activity is we are unable to see the charge. We can only do this type of activities and observe it in the form and try to understand what it is. Okay, let us get into the topic again. I hope you understood electric charge clearly with the activity. There is one more activity on paper electroscope. I'll give in the description box. Just check it out. You will understand better after going through that video. So coming to our topic, electricity. Under that subtopic is electric charge, which we are discussing today. Okay, so what is the exact definition of electric charge? Electric charge is a property associated with the objects due to which they show electrical and magnetic phenomenon. That means, see, in the previous activity you have observed. So because of this charges only, the objects were able to show their properties of electrical and magnetic phenomenon. That means the scale was able to pull the papers towards itself only because of this charge present on the scale. So coming to the properties one by one. So the first one, electric charges are of two types. So by assumption, that we have assumed, because we don't know what it is, so we have given name charge to it, and by assumption only we thought that one is positive and the other one is negative, just like North Pole and South Pole. Okay, same way positive and negative, it is an assumption. Next, unlike charges attract each other and like charges repel each other. So if two positive charges are kept beside each other, they will repel. That means they move away from each other. Whereas if it can be positive or it can be two negative charges. But if one positive charge and one negative charge are kept, they will try to come together. So this is the main basic property of electricity in electricity topic. Because using this property only, there is charge flow in the conductor, which I am going to discuss in the next topics. Okay, so keep this point in mind. It's very, very important. Unlike charges attract each other and like charges repel each other. Unlike means two different, positive and negative. Like charges means positive and positive, negative and negative. Then coming to the third point, net electric charges can neither be created nor destroyed. As you know, anything in our matter or present around us, and even the energies cannot be created nor destroyed. Same way, the charge cannot be created nor destroyed. It can only be conserved and it can be transferred from one object to the other. Then electric charges are quantized in multiples of E. What is this E is? It is the value given to the electron. So that I will discuss in detail next. What is the value and what it is. Charge is a scalar quantity. That means it doesn't depend on direction. So we have scalar quantities, vector quantities. 9th standard, when motion topic comes, then scalar and vector is given in detail. So only value dependent physical quantity is there. Then we call it as scalar quantity. For example, we say milk is in liters. It is scalar because it doesn't require any direction. Same way, charge is also a scalar quantity. So let us see what is this electric charge being quantized. So it is given, put in the form of equation Q is equal to N into E. What is this Q? Q is the net charge. What is net charge? See, when an object is rubbed against each other, you have seen that electrons are getting settled on one object. So this accumulation of charge is called as the net charge. Okay, it is one part accumulated charge, that is called as the net total charge. So this total net charge is called as Q. Why we are doing this is we measure everything. Okay, whatever we are using, everything we will measure. So simply to measure the electric charge, it is said as it is multiple n multiple of E, where E is the magnitude of electron. Magnitude is nothing but value given to the electron, that it is, as electron carries negative charge, so it is 1.6 into 10 power minus 19 coulombs. We are not writing minus here because it is neglected over here. So SI unit of charge is coulombs. So as we have for milk liters or some mass kg, same way this net charge has a unit coulombs. We measure it in coulombs. So there is a conversion over here. 1 millicoulomb is equal to 10 power minus 3 coulombs and 1 microcoulomb is equal to 10 power minus 6 coulombs. This is just conversion which will be useful for you in problems. Okay, so as an atom has at the center nucleus and protons, as I told you in the introduction, so protons, what are these protons? Protons are positive and electrons are negative. So electrons can only move because in the proton the nucleus is tightly catching this proton. It is inside the nucleus, so it's not going to come out. So this electron is moving. So we are worried about the electron. So whatever the current topic you are going to study, it will be related totally to the electron flow, charge flow. So that is the reason we have taken net charge is equal to multiple of magnitude of electron. So okay, suppose if you want to find out what is the number of electrons in 1 coulomb of charge, then we can just convert this formula this way. N is equal to Q by E, just by sending Q the other side. So we will get, as we know the value of electron 1.6 into 10 power minus 19 coulombs. Then we get 6.25 into 10 power 18 electrons. It's very interesting, right? So 1 coulomb of net charge contains 6.25 into 10 power 18 electrons. See how we measured, how beautifully the method is given to us. So just I will summarize what we have learned today. So our topic is about electricity and you have learnt about the electric charge and properties of electric charge and how these electric charges are quantized. So in our next topic I will continue with the voltage, what is potential difference. I hope you understood. If any doubts, please do comment in the comment section. Thank you.